Hey guys, in this video we're going to take a look at limits as x approaches infinity, okay? So that's what we're going to do here. Let me just show you two important parts that you need to know in order to do these very easy problem. Now, this function here is going to be 1 over x, okay? This is what it looks like. You guys can either look at it using a graphic calculator or you can just plug in some points, like at 1, you get 1, at 2, you get a half, at 3, and so on. You get a third. Okay. And then on this side of it, we get this piece of the graph. On this side, we get this piece of the graph. We have a vertical asymptote at x equals 0, which is this guy right here. So the graph will never touch this. And we also see that it has a horizontal asymptote here. So basically, what's happening here is that as the limit, as x approaches infinity, that means all the way out here, okay? As the limit as x approaches infinity of 1 over x, where is this graph going? Where is this graph going? This graph is going to the y value 0. So this is what we're going to need to do these problems. So just know that part. I know I'm only looking at x approaches infinity, but I will make a comment at negative infinity at the end of this video, okay? So that's the first step that we need. 1 over x is equal to 0 when x approaches infinity. This is 1 over x squared. In this function, it looks just like the last function, except for instead of quadrant 3, we're in quadrant 2. It flips because the x squared turns all the values, the y values, to be positive. But regardless, the limit as x approaches infinity, that's out here, x gets really large. Where is x going? X is going toward, where is y going? Y is going towards 0. So once again, this is 0. And I'm just gonna say in general, when you have a variable in the denominator and you're looking at what happens when x approaches infinity, it always goes to 0. So we looked at it here, it was x to the first power. We looked at it here, it was x to the second power. The same rule will apply for x to the third, x to the fourth, and so on. The limit as x approaches infinity for 1 over x squared or 1 over x or 1 over x to the third will always be 0, okay? Now the rest is gonna be easy. So the blue is my function, f of x. F of x equals 3x squared plus 4x plus 2 over 5x squared minus 4x plus 1. I just made up this function. I'm going to show you the long way how to do it, and then right after this problem, I'm going to show you how to do it really fast. But I want to show you where this comes from. What you do, I'm going to look at the limit as x approaches infinity for this, okay? For f of x. What you want to do is you want to take the x with the highest exponent in the entire problem. So in the numerator, the highest is x squared, and the denominator is also x squared. So I'm just going to choose x squared. So what you do is you just take x squared and you divide each piece by x squared. X squared. X. So I took 3x squared over x. I took everything in this numerator and divided it over x squared. I did the same thing for the denominator. Once you do that, this is going to reduce to this guy right here. 3x squared over x squared is just 3. 4x over x squared leaves you with an x in the denominator. And this guy here, well, that's just 2 over x squared. We do the same thing for the denominator here. 5x squared over x squared gives you 5. This gives you him, and then this gives you him. Okay? So, with that being said, I'm left with the green now. So I'm left with this. That's great. What is the limit as x approaches infinity of f of x? Well, if you remember from the first page of this, anytime you have an x in the denominator and you're looking at the limit as x approaches infinity, those are 0. So boom, 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 boom. Those all go off to 0. There is no x here to plug in your infinity, and there's no x here to plug in your infinity, so this is just going to give you 3 over 5. In other words, if you go back and you graph this beautiful function, you will see that it will level off at 3/5. Okay, so there's a horizontal asymptote at 3/5. Okay, so you're probably saying to yourself, is there a quicker way than dividing by all this? Absolutely. All you guys have to do is grab the x with the highest exponent in the numerator. So that's him. Take the coefficient, which is a +3. Take the one in the bottom. That's the highest. Take them off to the little corner. Have a talk with them. Reduce them. Okay. That's 3/5, and that's it. You might say, well, what about the 4x and the 2 and the -4x and the 1? Well, you can see that these guys really don't matter because infinity means what happens at the very, very end. And really, if you had like $1 billion, you probably wouldn't be watching this video. But if you had $1 billion and you just add $1, it really is not going to change anything. So we only care about the highest exponents when we're talking about infinity, okay? So they have the most effect on the problem. So just grab the highest in the numerator, highest in the denominator, and then reduce them and see what happens. So let's try these really quick problems in under a minute. Let's go. Okay, find the limit as x approaches infinity of this function. I'm gonna go and highlight, because it says infinity, this is the only reason why we're doing this. I'm gonna grab the highest in the numerator, that's x to the third. I'll take his coefficient, 5. I'll grab the highest in the denominator, 7x to the third. And all I'm going to do is I'm going to do this, and then I'm going to reduce it, and I get 5/3. So the limit as x approaches infinity for this is 5/3. And of course, my upstairs neighbor wants to vacuum while I'm making this video. So sorry about that noise. It's like you had the entire day to do it, and now you want to do it. Okay, so that's 5/3, all right? Let's try the next problem. Find the limit as x approaches infinity, okay, of this function. So because it says x approaches infinity of the function f of x, we're going to go and grab the highest, and then that's that guy. Be sure that sometimes it's not in order, okay? And then you got to take the highest here, and that's that person. And then you're going to rewrite them. So take the -7x to the third and the 14x to the third and reduce it, and you're going to get -2. Okay, so that's that guy there. Okay, let's see what happens when they don't match. In all of these examples, we saw that they match. Let's see what happens when they don't match. So in this case here, the limit as x approaches infinity, I'm going to see that they don't match, but let's reduce them. Well, I get a 5x squared. Okay? Now, there's an x in the denominator. I want you to think about it like this. A large number squared becomes even larger. 7 over a very large number, let's say a billion, a trillion, right? If I give you $7 out of a trillion, I'm basically giving you nothing. So anytime you have an x squared in the denominator, or an x in the denominator, or x to the third in the denominator, anytime you have a letter left in the denominator, it's 0. Because 7 over a trillion is 0, okay? So that's what you do there. And you can also remember from the graph on the first page that 1 over x squared as x approaches infinity is 0. Let's try one more. So the limit as x approaches infinity, let's grab the highest on top. Oh, look, I almost fell for it. It's right there, okay? So that's gonna be -7x to the 6th. What's the highest on the bottom? Positive 2x squared. When you reduce it, you're left with -7 over 2x to the 4th. What happens when you put a really large number here? It becomes larger, right? So infinity to the 4th is infinity, but times it by this negative, it became negative infinity. So this guy here is infinity. The 7/2 is not going to have an effect on him, so we don't care about that. But timesing him by the negative basically says, hey, as you go more and more to the right in the graph, this graph is going to start going down. Okay, because remember that this is the y. So where's the y going? So it's going down. Okay, let's try rapid review. Let's see if we can get this. Find the limit as approaches infinity, as x approaches infinity in each of the problems. highest on top, highest on the bottom. Oh my God, that noise. Okay, so that's that. We're gonna reduce it, and we're gonna get -1/2. Why? Because there's no more x's there. So there's no x to plug in the infinity. Let's try the next one. Where's the highest on top? Where's the highest on the bottom? Let's reduce this. Okay, she finally stopped. All right, and let's get -5x/7. Well, put your infinity in here. What is infinity to the first power? Infinity times a negative, I don't care about the 5/7, times a negative, so this is going to be negative infinity. That's where that's going. Okay, final problem of the day. Grab the highest on top, grab the highest on the bottom, and then we're going to reduce it. When you go to put infinity here, infinity looks something like this. 4 out of a trillion, zillion, you get 0. Okay, so this rule of grabbing the highest on top and the highest on the bottom only applies when the limit as x approaches infinity. And basically, if it was negative infinity, you would just do the same exact rules, okay? So good luck, have a great day, subscribe to the channel, send it off to your friends in college and all that great stuff.